Review 6, a real EMF device. The figure shows a circuit with a real EMF device with an EMF of 30 volts and an internal resistance of 1 ohm. Note the switch at the bottom of the figure, right there. When it is open, what will be the voltage measured across points A and B? When that is open, then the voltage measured across this real EMF device, and I'm showing that it has internal resistance, will be numerically equal to 30 volts. Now we're going to close the switch, and we want to know what's going on here. What's going to be the resistance that is perceived by the battery? What we're going to have is we're going to have this portion right here. Those two resistors are in parallel. Let's find the equivalent resistance of that. We're going to go 1 over 6, which is 2/12, plus 1/12, which is 3/12, flipped upside down, so that's 12/3, which is 4. The equivalent resistance of this portion is 4, which is in series with this, so 4 plus 5 is 9, plus the resistance of that, so the total resistance is going to be 10 ohms, which means the current that's going through the battery is going to be 3 amps. What else are we going to know then? Well, then the current through the 5 ohm resistor is also going to be 3 amps. And once that current gets to this point that I'm pointing at with my pen right here, there are a number of ways you can do this, but because the numbers are simple, we're going to just use our brain here, and we're going to say that 2/3 of the current will go this way, and 1/3 will go that way. In other words, twice as much goes this way because this portion has half the resistance of this portion, which means through the 6 ohm resistor, the current is going to be 2 amps. Through the 12 ohm resistor, it's only going to be 1 amp. And that means that the pressure difference across the 5 ohm resistor is going to be 5 ohms times 3 amps is going to be 15 volts. And across the 6 ohm resistor, it's going to be 12 volts. And across the 12 ohm resistor, it's also going to be 12 volts. Okay, that's good because those should match up, shouldn't they? The pressure difference across the 6 ohm resistor and the 12 ohm resistor should be the same, because if we were color coding those bits of the circuit, we would color all of this one color and then all of this region up here. There we go. You see that the pressure difference across both of those resistors is going to be the same, so that's going to be 12. When current flows through a real EMF device, there will also be a voltage drop across the internal resistance of the battery. What's the voltage drop going to be across the battery? We said that the battery is going to have 3 amps of current going through it. The voltage drop from one end here to the other, it will drop by 3 volts. 3 amps multiplied by the resistance of this real EMF device, which is 1. Which means, what voltage would a voltmeter measure across points A and B when the circuit is closed? Let me make sure we close that circuit. And current is running through it. It reads 30 volts between points A and B when there's no current running. But if there is current running, then there's a voltage drop of 3 volts. So our voltmeter will only measure 27 volts between points A and B whenever we've shut this and there are 3 amps running through the battery.